All right, everyone, welcome to section 7.6 on rational equations and formulas. Let's get started right away here. So today our objectives are to solve rational equations, recognize rational expressions versus rational equations, find graphical and numerical solutions. So we're going to be using Desmos a little bit just to kind of explain why a solution is a solution to these, and then solving a formula for a variable. We will not solve applications involving rational equations this time around. So let's go ahead and get into rational equations. So basically, if an equation contains one or more rational expressions, it's called a rational equation. Okay, so basically, if you have equations like a over b equals c over d, what we can do is cross multiply and then set that product equal to the other product. So AD equals BC in this case, if we have A over B equals C over D. So it's kind of like when we solve a proportion, right? Now, the only caveat with that is sometimes we have like A over B plus something right on this side, or A over B minus something equals C over D, and then we can't use that same method, and I'll show you guys that as well. So here are some equations, kind of solving them like we did, or like that last slide showed you guys with the A over B equals C over D. So we're going to cross multiply. And again, these are equations, and we can find what X is because we have this equal sign in here. Okay, X is going to be a value. If we don't have an equal sign, and we'll see that here next, or in a few slides, then we can just simplify it. But here we can actually solve and find what X is. So let's go ahead and do that. So to solve something like this, if I have 9 over 7 equals 4 over X, okay, what I do again is I cross multiply. So I'm going to take the 9 times the X, and I'm going to set it equal to the other thing. So 7 times 4, okay? And we know that 9 times X is simply just 9X. 7 times 4 is 28. Divide by 9 on each side, and you get 28 over 9, okay? So that one's pretty simple. If you have something like this, 6 over 2x plus 1 equals X, what I like to do here is I like to put X over 1. Okay, because I can put any number or any variable over 1. It doesn't change the problem at all. So what we do here is, again, we cross multiply. So I take the 6 times the 1 and the 2x plus 1 times the X. Now, sometimes, you might decide, well, what is it better to write this as? Is it better to write 6 times 1 on the left side equals the 2x plus 1 times X on the right? Well, in this case, I think it's better to write this guy on the left-hand side. So I'm going to write X times 2x plus 1, because that's showing me that I'm going to need to distribute that X. And then I have the 6 times the 1 on the right side. Okay, and again, it doesn't matter if you write it the other way, right? You could do 6 times 1 over here equals 2x plus 1 times X, kind of like I did the last one. Okay, but it's just, this is the same thing, and I think it just kind of looks a little bit nicer for us. So let's go ahead then and keep going with this one. We have to distribute the X here, so this is going to give us 2x squared plus X, and then 6 times 1 is 6. And then what I have to do here to solve for X, because I have this X squared term, we kind of recognize that. And I'm going to move the 6 back over here to make this a trinomial. So 2x squared plus X minus 6 equals 0. And then I have to factor this guy. Okay, so just a review on factoring here. So let's actually write this over here. So a review on factoring, I have to multiply this term to 2, and then the last term to -6, and that gives me -12. And I'm looking for factors of -12 that add to 1, so I can split the middle term, and that would be 4 and -3. So when I do that, when I split this middle term into 4x minus 3x, now I can group this together. So I'm going to basically group this part, and then I'm going to group this part as well. And so this part I can take out a 2x, which leaves me with x plus 2. And here I can take out a -2, or sorry, not a -2, a -3. -3. And that leaves me with x plus 2. Okay. So then we combine here. So we have the 2x minus 3. And then we have the x plus 2, as we did back all the way back in chapter 6. And then now at this point, x is actually going to have two different answers. So I use that zero product property that we talked about a long time ago. And I break this up into two different equations. And then I solve for x. So here I'm going to add 3 and then divide by 2. So x is going to be 3/2. And then this one I'm going to subtract, I'm going to subtract the 2. So then my other answer for x is going to be -2. So x is equal to 3/2 or -2. And you can verify that yourself. You can actually substitute each of these values in separately and seeing if that equation works. And I will check a few of these answers later on here once we get into some of the more difficult equations. Okay, but we do have steps to solving a rational equation. So this is really for if we have other numbers in there and that it's not just a simple cross multiply problem like we just did. So basically, we're gonna kind of go back a little bit to last section when we were finding, or I guess one of the methods, method 2, I believe, was finding the LCD of the terms in the equation. So finding the least common denominator. And then you're going to multiply each side of the equation by the LCD. I actually like to multiply each term by the LCD. You're going to simplify and then solve the resulting equation, okay? And then we do want to check answers here, okay? Because we want to make sure that the value that we get for our answer does not make the denominator equal to 0. If you do get one that your answer equals 0, we reject that answer. It's called extraneous, okay? So it is basically what that means is it is an answer that you would get in writing out that equation and solving it, but it actually is not a solution. And that's because that number would make the denominator 0. Okay. I don't know if I have an example of that, but you will maybe need to be aware of that for your homework. Okay. So just be aware of that. But let's go ahead, let's solve this first one here. Okay. So what we have to do, what I want us to do first is determine whether you're given an expression or an equation. Okay. If it is an expression, simplify it and evaluate it for x equals 4. Okay. If it's an equation, solve it. Okay. So I give you two different things here. Is this a expression or equation? Well, you might obviously say that it's an equation because it has an equal sign. And I said that earlier. Now this guy over here, this whole thing in B is an expression. There is no equal sign. So in part A here, or in question A, you're going to be solving for x. In question B, you're just going to be simplifying it. So let's do A first. Now in question A, remember the first step was to find an LCD. So kind of similar to last section. Well, what is your least common denominator here? Well, you have a denominator of x plus 3. What could we do to the 4? We can write it over 1. So that's a denominator of 1. And then we have an x plus 3. So the LCD here in question A is just x plus 3. Okay. And that's important because what I'm going to do with that is I'm going to multiply that by each term here. Okay. So I'm going to take x plus 3, that LCD, and multiply it by this term, the 2x over x plus 3. Okay, and then I'm going to multiply it by this 4. So I have 4 times the x plus 3. And then I set that equal to x times x plus 3, or sorry, x over x plus 3 times that LCD of x plus 3. So you have your LCD 3 times because I have 3 expressions here. Okay, this guy, and this guy. And now what does that allow me to do? That allows me to cancel out your denominators. So that's a really good thing, okay? We don't want that denominator because we don't want to work with fractions. So I go ahead and I cancel out the x plus 3's. I can't do it here because I have a denominator of 1, okay? But here I have another x plus 3. So let's write out what we have left over after the cancellations. So I'm left with 2x minus 4 times x plus 3 equals x. And now I keep simplifying. So the next step, I cannot subtract these two. Sometimes people do that, and that's a common mistake. But I have to distribute this, really this negative 4. So I have 2x minus 4x when I distribute. And then negative 4 times 3 is minus 12. Okay. And then here, let's get the x's. Let's combine those. 2x minus 4x. Those are like terms. That gives us negative 2x. Minus 12 equals x. Let's get the x's to one side. So let's subtract an x here. And then add the 12. So I have negative 3x equals positive 12, divide by negative 3, and x equals negative 4. Okay. And we're not going to do anything else with that because, you know, it's an equation. It's not an expression. But I do need to, and I do want to check this. Okay. And let me do that in a different color. Let me just do that in green. So let's check that x really does equal negative 4 and that it's not an extraneous solution. And you can tell right away that it's not going to be extraneous because it doesn't make your denominator 0. If you were to plug negative 4 into either of these x plus 3's, it would give you a negative 1 in your denominator. So you don't have to worry about that. But let's just check it anyway, just to verify that we didn't make any mistakes. So how do I check? I plug it in, right? So we plug the negative 4 everywhere that we see an x. And if you want to, you can put a parentheses around that. Sometimes I do that, so I'm kind of emphasizing what I'm substituting. Okay. And then we simplify. So really we're asking ourselves, does the left side, does all of this equal the right side? And if it does, then it checks out. Okay, but this is not going to be your answer. This is just checking is negative 4 the answer? Does the left side of the equation, the original equation, equal the right side? Well, let's simplify. 2 times negative 4 is negative 8 divided by negative 4 plus 3. Negative 4 plus 3 is negative 1. So negative 8 divided by negative 1 is a positive 8. And 8 minus 4 is 4. So the left side is equal to 4. Does the right side equal 4? Well, we have negative 4 divided by negative 4 plus 3. Negative 4 divided by, this would be a negative 1, is 4. So yes, 4 equals 4, it checks. So this is your solution, x equals negative 4. All right, let's go on to B now, okay? So this was our expression. And because it's an expression, they do want us to substitute x is equal to 4 at the very end, just because, okay? And again, how do you know it's an expression? There's no equal sign, okay? But when we simplify an expression, we need to have a common denominator. And you can see here that we already do in this one, okay? Both denominators are x minus 2. All right, so both denominators are x minus 2. I keep that denominator and I add or subtract the numerator. So the numerator is going to be that x squared plus 3x minus the 10. Okay, that's all your numerator. And then we notice here, this is a trinomial. I can actually factor it. So factors of negative 10 that add to a positive 3 are positive 5 and negative 2. And then here, at this point, because you have all multiplication, right, and you have your factors, you can cancel the x minus 2's. So then this one is just simply equal to x plus 5. Okay, so again, in an expression, we're not solving for x, we're just simplifying it. And then they also wanted to have a substitute. So if x is equal to 4, okay, what is x plus 5? Okay, well, it's just simply 4 plus 5 or 9. Okay, so that is all for those ones. I think I have 2 more examples that I wanted to do. Again, these are going to be a little bit harder. Oh, actually, before I do that, let's go back to the equation one. Let's go back to part A. So this was part A. Okay, and what I wanted to do is I wanted to solve this graphically using Desmos. So I wanted to verify, or I want to verify that the answer is x is equal to -4. Okay, using Desmos. So let's get out of this screen for a moment and let's go to Desmos. And I'm going to type those equations in. Now, one important thing, actually, let me go back to the PowerPoint. One important thing to remember about this is when you're graphing, okay, when you're graphing, it's y equals something, or remember back to the graphing unit, it was f of x equals something. So it's this side and this side. Those are 2 separate lines, if you will, or functions. Okay, so one function is y equals, or f of x is equal to 2x over x plus 3 minus 4. And then the other one is y equals x over x plus 3. Now, when you graph this, we're going to kind of see what happens. And we're going to see why x is equal to -4, and there is your answer. Okay, so -4 would be your answer for that. So let's go back to Desmos now. So again, the whole point of the y equals is that's going to be what I'm going to write here for the function. So I'm going to write 2x divided by, oops, I'm not sure what's going on there. 2x divided by x plus 3 minus the 4. So there's a function. And then x over x plus 3. Okay, now remember, where do we have a solution? We have a solution where these functions intersect, okay? Where these functions intersect is the solution. So you can see down here, these actually are never going to intersect. They're never going to touch. You can keep going all the way. They're never going to touch, okay? But over here, they still are never going to touch, okay? But we see here that we do have one point exactly where they do touch, and that's this point here, -4, 4. Okay, -4, 4. So let's go back to our slideshow. So we saw that these 2 functions intersect. They intersect at the point -4, 4. Okay. And so that is why your solution to this was -4, because that is what x is equal to. Okay, so our solution was x is equal to -4, and that happened to happen at y is equal to 4. So when y, yeah, so basically at that point is where these 2 functions intersect. All right. Now let's go on to a different homework problem. So this one is probably going to be the hardest question that we're going to have on here. And that's because of just its long LCD. So again, the first step when you're solving this rational equation, again, I know it's an equation because of the equal sign, is to find the LCD. Well, remember the LCD was basically you need a multiple of everything. So of all of your bases here, okay? So you need your denominators to be your LCD. So I have a denominator of y minus 1, y, and 9. And remember, y minus 1 is an expression in itself. So we also need that for our LCD. So your LCD is going to be 9 times y times the y minus 1. And I have to multiply each term by that LCD in order to get rid of the fractions. That's the whole point. I want to get rid of the fractions. So I'm going to take this LCD, 9 times y minus 1, and I'm going to multiply it by each term. Okay. So I multiply it by 8 over y minus 1. I multiply that by 1 over y. And then I multiply it again by 10 over 9. And then the whole point of that is to make these fractions cancel, make the denominator cancel. So the y minus 1s are going to cancel here. The y's cancel here, and the 9s cancel here. So what do I have left over? Let's write it out. So I have a 9y times 8 plus 9 times y minus 1 times 1 is equal to y times y minus 1 times 10. Okay. Y, or 9y times 8, that's 72y. 9 times y minus 1 times 1, well, let's just leave that as oops, wow. Let me rewrite that, sorry. Let's rewrite that as 9 times y minus 1, right? Just times the 1 there. And then the 10, I'm just going to write out front. So it's going to be 10y times y minus 1. Now let's distribute. So let's get rid of the parentheses. So we still have the 72y. Let's distribute the 9 into y minus 1. So I have 9y. That's just a y there. That's 9y minus 9 is equal to, when I distribute the 10y to y, that's going to give us a 10y squared. Uh-oh, okay, so I'm going to have a trinomial minus a 10y. Now let's combine like terms. So on this side, I have these two guys, 72y and 9y combined to 81y. And then now what I want to do is let's move everything to one side. So let's get this equal to 0. So I'm going to minus the 81 over here, and I'm going to add 9. So I'm going to have 0 equals 10y squared. I just want to keep this one positive. That's why I did it the other way. Negative 10y, I'm subtracting 81y. That gives me a minus 91y. And then I added 9. So that's my trinomial right now. And then I need to factor this. Okay, so I am going to have more than one solution for the variable y here. So let's factor. I need factors of 90, right? I took the 10 times the 9. 10 times the 9. I need factors of 90 that add to negative 91. Well, that's pretty easy. It's negative 90 and negative 1. So this one is going to be 10y squared plus 90, not plus 90y, minus 90y. Minus 90y minus 1y plus 9. So let's continue factoring. Common factor of 10y squared minus 90y, remember I'm grouping now, is going to be the 10y. So I have y minus 9 left over. And for this one, let's take out a negative 1. So that's going to, again, leave me with the y minus 9. And so I have 10y times negative 1 times y minus 9. Those are my two factors. And then again, I use that zero product property, and I set each of these equal to 0, and I solve for y. So this one, I add 1 and I divide by 10. I have y equals 1 over 10. And then this one, I just add 9. So I have y equals 1 over 10 and 9. Okay, those are your solutions there. Again, you can check to see if those make your denominator 0. Neither of them would if I would substitute. And those are going to check out. Okay, those are going to check out. Again, it does say to check your answer. You can do that. I can plug in the 1/10 here. So I'll just say I have a little bit of space up here. I'm going to do it here. I have 8 over 1/10 minus 1 plus 1 over 1/10. Does that equal 10 over 9? Well, this is going to be 8 over 1/10 minus 1 is negative 9/10. Oh, this is getting a little complicated. Plus 1 over 1/10. Well, 1 over 1/10 is actually going to be 10. So does that equal that? Well, if you took a calculator, or actually you don't even have to take a calculator here, but you would get, actually let me do that. I don't want to think too hard today. So it's 8 divided by -9. Let's see, -9 over 10. And that gives me, oops. Let me try that again. 8 divided by -9 over 10. That gives me -80 over 9. That gives me -80 over 9 plus 10. Does that equal 10 over 9? Well, -80 over 9 plus 10 is in fact 10 over 9. So yes, 10 over 9 is equal to 10 over 9. So that one checks. And then we can plug in 9 here. So we got to check the other answer. So 8 over 9 minus 1 plus 1 over 9. Does that equal 10 over 9? So basically, does 8 over 8 plus 1 over 9 equal 10 over 9? And yes, it does, because 1 plus 1/9 is equal to 10/9. Okay, 1 is 9/9. If I take 9/9 plus 1/9, it's 10/9. So both of those answers check out. So that is a homework problem, and that is quite the homework problem. I did want to include that on this lecture because, again, this is a tough one. But I think the biggest thing that people mess up on is the LCD. Okay, make sure you include all of those terms in there because they're all different. Okay, if you did have something that was the same, you would only need it one time. So, all right, and then another homework problem. This one is actually much easier. So this one, again, the first thing you ask yourself, okay, do you have an equation or an expression? Well, this is an equation. If it's an equation, we need an LCD, and we need that LCD because we're trying to cancel out those fractions, okay? In a expression, you're not trying to necessarily cancel the fractions out, okay? In the example that we did earlier, the fractions did end up canceling out, but only after we factored everything and then simplified, okay? But here, let's find the LCD. Well, we have denominators of 4x and 3x plus 4. So if I just multiply those together, that is going to be your LCD, okay? Because they have nothing in common. Those two are not the same terms. We need both of them. So again, the first thing you do, okay, take your LCD and multiply it by each term. I take the LCD and I multiply it by 1 over 4x. Then I take the LCD again and multiply it by the 1 over 3x plus 4. And this one's equal to 0. Oops. And then we go ahead here and we can cancel. So I cancel the 4x's here. I cancel the 3x plus 4 is here. That gets rid of the denominator. So I'm just left with 3x plus 4 times 1. I'm not going to write the times 1 this time. And then minus 4x times 1. I don't need to write times 1. So then we just combine like terms. I have a 3x and a minus 4x on the same side gives me a -1x. -1x plus 4 is equal to 0. Subtract the 4 and then divide by -1. So x is going to be equal to 4. Okay. And again, you have to check if that's an extraneous solution. And again, you can see this is not going to be extraneous because it's not going to make your denominator 0. But I still want you to check. So does 1 over 4 times 4 plus, there we go, minus here, minus 1 over 3 times 4 plus 4. Okay, does that equal to 0? Well, 1 over 4 times 4 is 1 over 16. 1 over 3 times 4 is 12, plus 4 is also 16. And when we subtract 1 over 16 from 1 over 16, we get a 0. So this checks out. So x is equal to 4 is your answer. And guys, that is all on these rational equations and formulas. So we will do one more section. section 7.7. And we'll see you next time for that. So please let me know if you have any questions on 7.6, especially if you run into one that has the extraneous solutions on it. So until then, see you guys.